So we talked about pi and p electrons being moved around in our models to either stabilize positive charge or stabilize negative charge. And until you practiced a little bit with resonance and with mesomeric effects, it can be a little bit counterintuitive. However, something that you should have encountered before is the other major electronic effect, which we call inductive effect. And we think of this being associated mostly with sigma electrons, although you can sometimes apply it in very simple systems to s electrons. And inductive effects are all to do with electronegativity. Consider this bond here between two atoms, X and Y. And I'm going to say that Y is the more electronegative of the two, so therefore this polar bond, slightly positive X, slightly negative Y, because of course electrons are drawn more towards the more electronegative atom, giving it that extra electron density. Okay, now that is something you've seen lots and lots and lots before. We can think of this in two ways. We can think of it as Y is pulling electron density away from X. So what we'd say there is it has a negative inductive effect on X. It's removing the electron density from X. It has a negative effect. Conversely, we could think of it the other way around. We could say, well, maybe X is just pushing electron density towards Y. Well, if it's pushing electron density towards Y, it's got a positive inductive effect. It's giving Y some electrons. And we use the same kind of idea, plus and minus, but instead of M for mesomeric, I for inductive. Okay, now, again, we don't care about general bonds. What we care about here are atoms bonded to carbon. Okay, now if carbon's bonded to anything, pretty much any of the interesting atoms that we think about, those atoms are going to be more electronegative than carbon. So that's if the carbon's bonded to any halogens, if it's bonded to oxygen or nitrogen, if it's bonded to a carbon or a sulfur that's bonded itself to oxygens or nitrogens. Thus here, for example, cyanide, the acid group, the carbon normally wouldn't have a big deal on this carbon, but because this carbon's bonded to other oxygens, it's going to be pulling electron density away from the carbon. So all of these things that are more electronegative than carbon have a negative inductive effect on the carbon. They're pulling electrons away from it. So if we have one of these groups attached to a benzene ring, which is of course what we're mainly interested in right now, any of these groups bonded to a benzene ring will have a negative inductive effect on the benzene ring. They'll be trying to suck electron density away. Now there are some things that have a positive inductive effect on carbon. First of all, if a carbon bonded to a carbon that doesn't have any of these other electronegative atoms, you tend to think of these as having a positive inductive effect. So if we have a methyl group attached to the benzene ring, it can push electrons into the benzene ring, sigma electrons into the benzene ring. And of course, although we're not going to talk much about so-called organometallic compounds, at least not in the core modules, but lithium organic compounds, magnesium containing organic compounds, very, very important. Metal atoms are of course less electronegative than carbon atoms, so we can say that they have a positive inductive effect on the carbon. They are either, you can say they're pushing electron density into the carbon, or of course the carbon is pulling electron density away from those. But I like to think of when it's a negative inductive effect, that is the atoms are pulling electrons away. When it's a positive inductive effect, the atoms are pushing the electrons towards. So now we're armed with mesomeric and inductive effect understanding. Let's see if we can't actually apply it to discussing substituted benzene rings.